private ke? Tak dapat. Local public. Okay, bismillahirrahmanirrahim. Okay, Assalamualaikum warahmatullahi wabarakatuh and selamat pagi. Hari ini kita akan bincangkan soalan tutorial bagi question number 18 until question number 22. Okay, so on the screen, say the lattice energy of NaCl is negative 776 kJ per mole, and the enthalpy change when 1 mole of solid NaCl dissolved is positive 4 kg per mole. If the enthalpy of hydration is if the enthalpy of hydration of Na plus is negative 390, calculate the enthalpy of hydration of Cl minus. Banyak ayat dia ni, okay. So saya buat by baris-baris. Lattice energy of NaCl is negative 776. So okay, and then enthalpy change 1 mole of solid dissolved di sini. Di bawah enthalpy of hydration Na, so then enthalpy of hydrogen Cl minus. So here we have a total of 4. First one, lattice energy NaCl, and then NaCl dissolved in water solution, and then hydration of Na plus, and last one, hydration of Cl minus. Okay. Okay. So kita kena buat satu persatu dia punya chemical equation. So let's start with the lattice energy of NaCl. Right. So untuk lattice energy NaCl, if they give you negative sign, okay, saya fokus pada negative sign di sini, okay. Itu bermaksud that means the equation is lattice energy formation. lattice energy formation. Okay. Right. So lattice energy formation means, so you starting with Na plus gas plus Cl minus gas to produce NaCl solid. So if you starting from gas ion to produce NaCl solid, so your value of delta H will always be negative. So given value is 776 kilojoule per mole. Sometimes soalan dia akan bagi the lattice energy of NaCl is positive. Bila positif bermaksud equation tu dia reverse. NaCl solid tukar jadi Na plus gas and Cl minus gas. Or if you want to fix with this kind of equation, meaning you starting with gas ion and then you want to produce NaCl solid, or gas ion to produce solid, and then your delta H will always sentiasa negatif. Sebab lattice energy dia boleh bermaksud formation or dissociation. If you refer to question 6, we already covered two definition: lattice energy formation and lattice energy dissociation. The only difference is the sign, plus minus. Formation will always negative, dissociate always positive. Okay? But the question always say lattice energy only. Dia tak mention pun formation or dissociation. So you need to refer to your sign. Negative meaning formation. Right. So this is the first chemical equation. The second one is enthalpy change. 1 mole of NaCl dissolved in water. So this is enthalpy of solution. NaCl solid. Dissolved in water, it will produce Na plus aqueous and Cl minus aqueous. The given delta H is positive 4 kilojoule per mole. The third rule, enthalpy of hydration. So hydration meaning you start with gas ion, it will produce Na plus gas lagi aqueous. Okay. So start with gas ion, it will produce aqueous ion. Given the delta H negative 390 kilojoule per mole. Kemudian last one, calculate enthalpy of hydration of Cl minus. So Cl minus gas converted into Cl minus aqueous. And the delta H is unknown. Okay. Then calculate enthalpy hydration Cl by using energy cycle. So instead of cara algebraic method yang kita dah belajar pada hari Selasa hari tu, previously. So instead of using algebraic method, the question asks you to use energy cycle. So to use energy cycle, it always advisable you guna equation yang paling panjang. So either you choose equation 1 or equation 2. Itu yang paling panjang lah. Bila ada banyak benda kan dalam tu. Okay. So kat sini saya akan ambil equation 1 sebagai saya punya starting equation. Okay. So ini 3, ini 4. I'm going to label this is as delta H1, delta H2, delta H3 and delta H4. Untuk saya nak masukkan dalam table nanti. Okay. So tak muat. So saya mungkin ke bawah. Right. So the first equation is from Na plus gas. Sorry. Right. So Na plus gas and Cl minus gas, it will produce NaCl solid. And this is our delta H1. Next one. Okay. If you look at equation 3, we start with Na plus gas as well, similar to the first equation, Na plus gas. So you straight away use the third chemical equation. So Na plus gas going down, it will produce Na plus aqueous. Okay. If you refer to the one to the equation above, this is delta H3. And then Cl minus will produce Cl minus aqueous. And this is delta H4. So yang ni yang kita nak cari. And delta H2 belum masuk lagi. So delta H2 is from NaCl solid to produce Na plus aqueous and Cl minus aqueous. So it will be the last one is from NaCl solid here yang hujung ni turun ke bawah to produce Na plus aqueous. Ni kita tambah positive sign kat sini and Cl minus aqueous. And this is our delta H2. Okay. So kat mana kita start? So our starting point should be sini. Kat sini. Sebab from here kita ada semua anak panah keluar. So this is where the reaction start. Sampai je. Okay. And the reaction will stop at pergi ke kanan, turun bawah. Maksud yang ni. So this is where the reaction will stop. Okay. So from start to you, from your starting point to your stop, or your end point. So it will either go to the right and then going down, delta H1 and delta H2. So delta H1 plus delta H2, kemudian the stop equal another way, straight away going down, delta H3 and delta H4. So delta H3 plus delta H4. So this is the formula for this cycle. So we just substitute the value of delta H1 to 3 to find the value of delta H4. Right? So delta H4 is equal to delta H1 plus delta H2. 3 dah pindah sebelah, so minus delta H3. So refer back to tutorial mana? Okay, tutorial Thermochemistry nombor 16. Right. So delta H1 is our lattice. So dia jadi negative 776 plus this is solution 4 minus delta H3 is hydration Na given negative sign, so negative 390. Yeah. So final answer should be negative 382. Q18 unit kilojoule per mole. dapat So ini untuk question number 18 sebenarnya. Cuma nak kena mahirkan buat chemical equation. So these 4 chemical equation are not given to you. You need to write down the chemical equation on your own, including the phase symbol. So that's why question number 2 yang memula hari tu, question number 2 you need to alert with your definition. Right. So that is for question number 18. So number 18 buat turun bawah. Okay. Number 19, it says lattice energy for potassium fluoride is negative 8 to 1. So saya highlight dekat sini. Dia negative 821. Okay. And then enthalpy of hydration is negative 819. So ini untuk enthalpy of hydration. Jadi lattice. Okay. Calculate enthalpy of solution. So potassium fluoride is Kf. So bila negative sign meaning kita akan produce that Kf. So dia should be produce Kf solid because this is enthalpy of formation. Okay. If you want to put straight away the value here also can. So it will be negative 821 kilojoule per mole. Okay, saya besarkan sikit saya punya scale. Dia nak panah. It will produce Kf solid. So it will starting from lattice energy. Solid ionic compound is produced from its element. So the element, produced from its gaseous ion. So the ion is F minus and K plus gas ion. Okay. So this is the lattice energy. And then kita nak buat apa? Dia kata its enthalpy of hydration. So you should focus to the word its kat sini. So ITS, its meaning kepunyaan dia, belongs to, and pula I. So it belongs to Kf. So yang diberi tu its enthalpy of hydration is negative 819. Dia refer kepada Kf terus. Kalau soalan atas tadi, soalan nombor 18, nombor 18, dia refer to individual ion Na plus and Cl minus. That's why the sentence is enthalpy of hydration of Na plus, enthalpy of hydration of Cl minus. Dia specific kat situ. But for question number 19, dia lebih general. Dia terus kepada its enthalpy of hydration. Dia straight away terus kepada Kf. Combine dua-dua sekali. So, these two combine. These two combine. It will straight away produce K plus aqueous and F minus aqueous. Okay. And then dia punya value given to you is negative 819. Negative 819 kilojoule per mole. And they ask you to determine the enthalpy of solution. Okay, so solution from Kf to K plus and F minus aqueous. Right, so yang ini kita nak cari okay. Boleh kan tadi? So kita starting starting point is here. Turut tak nampak tulisan tu ya. So this is where we start. And this is where the reaction stop. So negative 819 from this cycle, negative 819 is equal to, okay, jalan jauh sikit, negative 821 plus delta H solution. So I put as delta H sol. Sol meaning solution lah for this question. Tambahkan juga sol. So delta H solution is equal to negative 819 plus negative plus pula plus 821. So 19 tutup 1. Berapa dia depan 2 je? 4. 2. Kita akan dapat positif 2 only. Kilojoule per mole. Right. Settle number 19. So this is by using energy cycle method. Masih lagi Hess's law lah. Alright. Okay, habis part ini, kita sambung ke soalan nombor 20. Nombor lari 20 ni atas. Salah. Okay, number 20. Oh, number 20 ni dah masuk Born-Haber. Okay, so sebelum kita masuk Born-Haber, apa saya nak buat lah? Kita masukkan insert line dulu. Shape line. Okay, so below this line kita dah start nak masukkan pada chapter kita lah, new subtopic which is Born-Haber cycle ataupun Born-Haber. So this is Born-Haber. For Born-Haber dia akan pecah dua. So either you are using energy level diagram ataupun kita akan guna energy cycle. Which one is the easiest? Yang ni paling senang. Energy level diagram dia okey, cuma sama je. Dia lebih leceh, lebih time consuming, a little bit fussy lah to draw because it contains a certain rule. Energy cycle dia lebih bebas. Then Born-Haber dia akan involve quite a lot of enthalpy. Normally it will involve enthalpy of formation, lattice energy, what else? It will also involve ionization energy, involve electron affinity. It will also involve enthalpy of atomization. Okay. F for formation, lattice. IE is ionization energy. EA is electron affinity. Delta HA is enthalpy of formation. Okay. So this is the 5 enthalpies normally involved in Born-Haber cycle. So, saya akan tunjuk dulu energy level diagram, contoh. Kemudian saya akan baru tunjuk contoh untuk energy cycle. Energy cycle basically question number 19, 20, number 20, 21, 22, semuanya energy cycle tu. Okay. So, saya tunjuk dulu energy level diagram. Right. So, for energy level diagram, energy level diagram, okay. Dia ada dua rule sahaja, only has two rule. The first one is positive delta H. Okay. The arrow must going up, while if your value of number 2, ini, okay. If your value of delta H is negative, then your arrow is going down. Itu dia yang awak nak kena ingat. So, saya start dengan, tak muat bawah ni. Okay, saya pindahkan ke bawah. Okay. Energy level diagram, dia perlukan ruang yang agak besar untuk melukis. So, kalau awak ni salin, should be lebih kurang separuh ke A4 lah. Separuh ke? Jom semangat. Lebih kurang lah. Okay. Nanti awak pandai lah adjust. So, saya kecilkan saya punya scaling kat screen. Okay. Then we have our y-axis. Ni agak panjang lah juga sebenarnya. Okay. And here we label as energy. Tambah lagi satu lah. Okay. So, this is 0. 0 means you are starting from your element. So, saya tambah lagi sini garis kat sini. Okay. So, in this energy level diagram, saya nak guna, I am going to use NaCl sebagai saya punya example. Okay. So, for NaCl, okay, the first equation that we are going to write is for the enthalpy of formation. So, saya pindahkan ke sini jauh sikit. Saya nampak ke sini delta H F formation. Right. So, delta HF for NaCl. So, definition, 1 mole of NaCl is produced from this element. Element for Na is Na metal solid plus chlorine ada 1, so 1/2 of Cl2 gas. So this is enthalpy of formation punya equation lah. Okay, element saja je start dengan kosong. And then from Na plus, okay, it will produce, atas ni, okay. The first step that we are going to use is atomization. Okay. Atomization means we change from Na solid into Na plus gas. Sorry, Na gas only. So from sodium gas we produce sodium. Sorry, from sodium solid we produce sodium gas atom. Chlorine kita tak ubah apa-apa. So this is delta H A. A for atomization, for atom, sodium. Okay. And then we change for chlorine. So saya buat atas sikit ni. Ini untuk chlorine. So what we change is from Cl. Okay. So from half Cl2, it will become chlorine gas. Okay. Kalau tadi 1/2 Cl2, Now it only becomes Cl. Half of Cl2 molecule become one chlorine gas atom. Na tak ubah, so salin balik semula. Okay. So this is what we call enthalpy of atomization for chlorine. Right. And then after our elements become atom, then we can change them into ion. So what we're going to do is from Na gas, we're going to proceed with ionization energy to produce Na plus gas. So it become positively charged ion. Cl kita belum ubah. So biarkan sebagai Cl sahaja macam ni. Okay, settle. And then so saya buat somewhere in the middle kat sini, kita tahu. Right. And then from Na plus settle, and then from Cl minus, we're going to change into Cl minus gas, first electron affinity. Okay. So it will become Cl minus gas. This one Na plus maintain. Okay. This is electron affinity. Saya buat dia ke bawah sebab the first Ea always negative. Second, third and fourth and so on always positive. Only the first electron affinity is negative sign. Or senang kata, only when you are forming negatively charged negative 1 charged ion, then it will become first Ea, arrow going down, negative sign. If you are going to produce negative 2, negative 3 and so on, the arrow will going up due to positive delta H. And then from Na plus gas and Cl minus gas, it will straight away going down here to produce NaCl solid, and this is delta H lattice. Right, so saya nak label this one. This one is number 1. This is number 2. This is number 3. This is number 4. Ea is number 5. Lattice as number 6. Okay. So itu kita punya 6 steps. Energy level diagram dia kena buat step by step. So start with enthalpy of formation, yang itu, and then going up one by one. Na dulu ataupun Cl dulu, either one, tak boleh sekaligus. Dia tak boleh simultaneously, it must one by one. So solid here. So saya highlightkan apa yang berubah. Right. So from so Na solid, we change into Na gas kat sini. Kemudian from Cl2, yang ini dia become Cl sahaja. Seterusnya, dari yang normal tak ada charge apa-apa, dia jadi Na plus. Okay. And then chlorine neutral, dia become chlorine minus. Last kali baru ditukar jadi lattice tu macam tu lah, tak ada apa-apa. Right? So this is energy level diagram. And then how you are going to write down the formula, just look where you are starting from and where you are stopping. Kat mana kita start, kat mana kita stop. Okay. So if we refer to this diagram, yang ni sebab yang ni dah penuh, saya tak nak kacau kat situ. Saya conteng kat bawah. Saya nak tolak tepi. So based on our diagram yang kita dah lukis tadi tu, ada nombor 1 kat sini. So yang 1 kat sini dan kita ada nombor 2 kat sini, kita ada nombor 3, kita ada nombor 4, nombor 5 kat sini dan nombor 6. So from this diagram yang kita sketch balik daripada atas, so the value of number 1, we see delta HF is equal to delta H number 2 plus number 3 plus number 4 plus number 5 and plus number 6. So tambahlah semua sekali. So 1 yang bawah ni 1 equal to the sum of the rest of your enthalpy. So delta HF is equal to atomization Na plus Cl plus Ie plus Ea plus lattice. So dia banyak sikit lah kat situ. So ini untuk energy level diagram. Contoh sahaja. Nilai kita kira kemudian untuk soalan nombor 20. Okay. So energy level diagram sedikit leceh nak lukis sebab dia akan gunakan banyak you punya kertas. Memang space you guna besar. Okay, now saya nak tunjuk untuk energy cycle. Yang ni favorite. Even dalam soalan pun dia agak favorite juga lah untuk buat sebab dia lebih senang. Senang untuk lukis. Pengiraan dia sama. Okay. So still I'm going to use NaCl as my example. So Na solid plus half of Cl2 gas molecule to produce NaCl solid. So if we are using the same numbering as above, so this is our delta HF number 1. This is delta HF, our number 1, sama dengan atas tadi. Right. And then Na solid change into Na gas atomization. Half of Cl2 gas molecule become chlorine gas atom, Cl atom. And then from Na gas atom become Na plus gas ion. Chlorine gas atom become chlorine minus gas atom, gas ion. And then when these two are together, it will become NaCl solid. Okay. So by using the same numbering and labeling as above, solid to gas is delta Ha for Na, labeling as number 2. And then this is atomization of Cl, numbering number 3. Then Ie, so ionization energy for sodium, label as number 4. Ea of chlorine, label as number 5. Last one is our delta H lattice. Lattice numbering as number 6. Okay, so my numbering and my labeling for cycle and energy level diagram both are similar. Cuma ini cycle dia pendek sikit. Kita boleh buat side by side Na dengan Cl. That's why dia pendek. Right. Then kat mana dia stop, kat mana dia start should be similar. So this is all the arrow going out. So starting from here is where we start. Dan kita akan stop should be kat sini. So this is where all the arrows coming together. So this is where we stop. So from start to stop, kita akan dapat terus delta HF. There's one step sahaja. Delta HF equal, dah stop kan? So yang ini, lebihnya yang ini kita tambahkan. All the way to here. So 2 plus 3 plus 4 plus 5 plus 6. Tambahlah semua sekali tu. So delta HA for Na plus delta HA for Cl plus IE plus electron affinity and then lattice energy. Okay, boleh? So untuk formula dia tak semestinya delta HF equal semua sekali, bergantung kepada you punya anak panah. Let's say saya sketch lain. Saya tolak tepi juga. Okay, ini adalah rekaan pula. Kat sini saya start, dia pergi ke sini, kat sini saya stop. So this is delta HF. Kemudian dekat sini saya ada delta HA atomization. And then saya akan dapat IE. Dan kita ada EA and so on lah. Okay. So dah dapat ion. Once kita dah dapat ion, so biasanya saya akan buat ke atas daripada sini ion, then saya buat macam ni. Untuk lattice, ini kebiasaannya sebab dia bagi negative sign. Okay. Sometimes soalan bagi positive sign, dia boleh tukar you punya anak panah ni. Instead of going up, dia turun ke bawah. Okay. Dengan syarat delta H dia mesti positif. The value for delta H must be negative. Okay. So if the diagram become like this, so your formula will change. So you akan start from here to here as one step, and then from here to here for another step. So untuk yang dari sini pergi ke kanan turun ke bawah, so it will be delta HF plus delta H lattice equal. Okay, and then from top straight away to the bottom, we have delta H atomization plus IE plus EA. Right. So all of this depends on how you draw your energy cycle and where your arrow going. Ke kanan, ke kiri, atas, bawah atau pulang. So dia tak ada fix formula kat situ. Cuma yang nak kena ingat, if your delta H is positive sign, your arrow must from, okay, so this is our solid ionic compound, will go into, kat sini mesti gas ion. So, from solid to gas ion, delta H mesti positive. If you are from gas ion, here is gas ion. Gas ion go into solid ionic compound yang atas ni NaCl. So your delta H will always be negative. Yang tu je awak nak kena ingat untuk lattice energy. Okay, so itu je lah untuk Born-Haber. Dia punya intro, tak ada intro. Dia punya konsep for Born-Haber. Right. So kita sambung ke nombor 20. For number 20, use the data below to construct Born-Haber cycle for copper to oxide and then determine its lattice energy. Okay, copper to oxide. So saya besarkan balik benda ni. Copper 2 meaning copper 2 plus. Oxide, oxygen, the charge is negative 2. Ada 2 minus. Naik. Okay, so dia bagi benda ni. So yang ni saya tak nak tengok dulu table ni. Table ni saya nak taruh tepi. So kita nak buat Born-Haber cycle for Cu2 plus and oxygen 2 minus. So we always start with enthalpy of formation. So enthalpy of formation, we are going to produce copper solid. So start with copper solid element and half of oxygen gas molecule to produce CuO solid. Okay, and this is enthalpy of formation, delta HF formation. Okay, next, from our element we must change them into atom. So from copper solid change into copper gas atom, and this is enthalpy of atomization, delta HA for Cu. Okay, next we atom the oxygen gas molecule. So from half oxygen gas molecule become oxygen gas atom. Gas atom O saja, tak ada O2. So this is enthalpy of atomization for oxygen. Then from Cu gas we are going to produce Cu plus 1 gaseous ion. Oxygen gas atom to produce oxygen minus 1 gas ion. And this is Cu gas to Cu plus 1 is first ionization energy. Oxygen to oxygen minus 1 is our first electron affinity. And then from Cu plus become Cu2 plus gas ion. Oxygen minus 1 become oxygen 2 minus gas ion. Right. So plus 1 to plus 2 is second ionization energy, and then minus 1 to minus 2 is our second electron affinity. Okay. Cu2 plus oxygen 2 minus. So these two add up together. Oh, dah besar dah kali screen. Okay. So from the gaseous ion yang kat bawah ni all the way up to produce CuO solid. And this is what we call lattice energy. So this is delta H lattice. Okay. Since saya from gaseous ion to solid, so saya buat dalam bracket formation. Okay. Remember formation, delta H will always be negative. Yang bawah tu cuma tambahnya lah info. Okay. So kita dah dapat kita punya cycle. Sekarang kita nak masukkan dia punya nilai, all the values given. Okay. So if you are referring to the values given above kat sini, or you can refer to your tutorial booklet. So saya akan start dengan, okay, the first dia bagi adalah atomization of Cu. Atomization yang ini, so dia akan jadi, this one is positive 339. kJ per mole. And then first IE of Cu, positive 745. So 745 kJ per mole. Next one, second IE. This is 1960 kJ per mole. After that, atomization of oxygen. So positive 248 kilojoule per mole. First electron affinity, negative 141 kilojoule per mole. Second EA, positive 791 kilojoule per mole. Second sector, enthalpy of formation is this one, negative 155 kilojoule per mole. Okay. Saya punya screen terlalu itulah. Sekejap. Tekan lagi sikit. Right. So, dia suruh cari, calculate, use the data below to construct Born-Haber cycle and then determine its lattice energy. So, when you are using atau when you are constructing energy Born-Haber cycle, make sure you ada phase symbol, element you correct and include the value for delta H. Tak label yang color biru tak apa, you tak label pun delta HA tak ada masalah. Tapi the value must be there. 339248 tu kena ada. Labeling delta HA first ERE second tu tak wajib pun sebenarnya. Wajib tu ada nilai. Okay. Sebabnya let's say katakanlah dekat sini for example only awak tak letak nilai ataupun tak letak phase symbol dekat CU kat situ. So bila you hilang ataupun you salah satu simbol ke apa kat situ tengah-tengah, awak akan hilang dua markah sebab markah yang pertama adalah daripada CU solid jadi CU unknown ni, ini awak dah hilang markah. Dan dari unknown ke seterusnya pun awak dah hilang markah. So that's why phase symbol tu awak kena alert untuk part yang ini. Tapi kalau awak tersalah nilai delta H ataupun awak tak letak, awak cuma hilang satu markah part situ je lah. Yang lain tu tak kacau. So make sure bila you letak balik you punya nilai, make sure you check balik you punya table, you put in the values correctly. Mana pen ni? Okay, so now let's calculate the value for delta H lattice. So far saya buat dia ke atas. So my answer expecting should be negative. Okay, so based on this cycle, so delta HF should be negative 1555 ni equal to the sum of the rest of our enthalpy. Okay. Delta HF equal to the sum of atomization CuO, first IE, first EA, second IE, second EA and lattice. Saya nak scroll down, saya tak nampak atas tu dah. So, delta HF equal to delta HA for Cu, delta HA for oxygen plus first IE plus second IE plus first electron affinity plus second electron affinity utama plus delta H lattice. Masukkan nilai. Mana ni tadi? Formation negative 155 negative 155 equal to atomization Cu 339 plus atomization oxygen 248 plus first IE 745 and second IE 1960, and then EA. First EA is negative 141 plus second EA 791. Oh, tak muat juga. Plus delta H lattice. So answer delta H lattice is equal to, tekanlah calculator, negative 155 equal 339 plus 248 plus 745 plus 1964 minus 141 plus 791 plus X. Chips of, so nilai X saya dapat negative 4097, negative 4097 unit kilojoule mole minus 1. Okay. Settle untuk question number 20. Okay, make sure you dapat lah. Tak dapat, Roger. Dalam WhatsApp boleh, dalam chat boleh. Kalau segan, WhatsApp senang. Senang. Okay, number 21. Use the data below to construct Born-Haber cycle for magnesium chloride and determine its lattice energy. Again, determine its lattice energy. Born-Haber cycle for magnesium chloride. Magnesium chloride. Okay, besarkan sikit. Magnesium chloride is, kenapa dia ni? Baru keluarkan, tadi tak keluarkan. Okay. Magnesium chloride is magnesium 2 plus chloride, sebab kita perlukan 2 plus, so dia akan jadi 2Cl minus. So table tolak tepi dulu, kita nak construct kita punya cycle. So from magnesium solid plus chlorine gas molecule, it will produce magnesium chloride solid. Okay, saya nak gapkan sikit saya punya elemen ni supaya saya senang untuk letak nilai kat tengah tu nanti. Plus magnesium solid. Okay. Saya saja je bagi jauh, senang saya nak melukis sebenarnya. Okay, so saya lukiskan dulu, baru saya label-label benda tu. Okay. So from element, this is element magnesium solid become magnesium gas atom, and then from magnesium gas atom it will become magnesium plus 1 gas ion, and then from plus 1 it will produce magnesium 2 plus gas ion. Okay. Here if we label, this is enthalpy of atomization for magnesium. And then this is first ionization energy, and this is second ionization energy. So dah alang-alang kat sini, kita terus masukkan dia punya nilai. Atomization of magnesium is 151. kilojoule per mole. First IE is 736 kilojoule per mole. Second IE is 1450 kilojoule per mole. Settle untuk magnesium. Now let's proceed with chlorine. So we are using 2 chlorine because we need MgCl2, 2 Cl kat situ. So from Cl2 molecule, it will produce 2 Cl atom, gas atom. So one molecule will produce 2 Cl atom. And then from 2 Cl atoms straight away going down, we will produce 2 Cl minus gaseous ion. Okay. Then we put in the label. Atomization of chlorine is, labelkan dulu. This is delta HA for Cl, and this is electron affinity for Cl. Cl. Okay. Atomization Cl mana? 1 to 1. Okay. The value is 1 to 1.5. Okay, dia bagi dalam tu kilojoule per mole, kj per mole. So yang ni saya biarkan dalam unit kj sebab saya kena darab 2. Why I must multiply with 2? Because we are producing 2 mole of gas atom. By definition, atomization is heat required to produce 1 mole of gas atom from its element. But in this equation, we are producing 2 mole of gas atom. So your delta H must be multiplied with 2. So the unit cannot be per mole. Now it becomes kg only. And then for EA, so EA given to you negative 184. So negative 184 also must be multiplied with 2. The unit become kg. So by definition of EA is energy release. Kalau first EA is energy release when 1 mole of electron is added to 1 mole of gaseous atom to form 1 mole of gaseous ion. Okay, saya repeat dia punya definition. EA, energy release when 1 mole of electron is added to 1 mole of gas atom to produce 1 mole of gas ion. So kita masukkan 2 mole electron dalam 2 mole gas atom to produce 2 mole gas ion. That's why kita kena multiply dengan 2 kat sini. So sini multiply with 2, this one also multiply with 2. And finally, last one, Mg2 plus with our Cl minus to produce kita punya solid ionic compound dekat atas ni. Since saya buat daripada gaseous ion to produce solid, so this one should be labeled as delta H lattice formation meaning saya punya nilai should be dapat negatif. If you want to do the other way around, still okay sebab itu yang kita nak cari, but you punya nilai akan dapat nilai positif. The value will be the same, just the difference between plus and minus sign. Itu sahaja. Okay. Oh, lagi satu saya tak label yang ni. Ini adalah delta HF formation. Apa dia nilai? Formation mana atas sekali? Negatif 645. Negatif 645 kilojoule per mole. This one we need to find out. Calculate. Okay. So, saya kecilkan balik kat situ. Again, based on this cycle, we should start at here. This is our starting point. And then dia akan stop kat sini. Bukan, salah. Stop mana? Atas. So, by this structure, delta HF is equal to the rest of enthalpy. So, saya tu dah masukkan nilai je lah. Saya tak tulis formula dah. So, delta HF is negative negative 645 equal to, saya besarkan sikit, negative 645 equal to, okay, atomization magnesium 151 plus, dapat atomization, kita ada atomization of fluorine sebelah dia. Fluorine mesti 1 to 1.5 multiply with 2 plus, and then kita ada IE 736 plus with second IE 1450 plus electron affinity. So this one is negative 184 times 2 plus with our lattice energy. Okay. So the lattice energy will be, apa dah tahu jawapan ni, delta H lattice is equal to negative 645 negative 2857 negative 2857. Unit is kilojoule per mole. Okay, dapat? Apa ni? 11 suku. So, kita dah masuk ke soalan yang terakhir. Dah lama dah. Sekejap je habis hari ni. Sekejap je. Okay. The last one, number 22. A Born-Haber cycle for the formation of calcium oxide is shown below. So, dia bagi dia punya cycle dah siap. Okay. Number A, what enthalpy change do delta H2, delta H6 and delta H7 represent? So, kita highlight apa yang soalan nak. Dia nak delta H2 and then delta H6 and delta H7. Okay, delta H6 ni dia bagi negative sign kat sini. So, kita fokus kat situ. 2 ni apa? 2 is IE. IE. 6 is lattice. Lattice formation, huruf F dulu. Kemudian 7 is delta HF. Right, nah, so kita tulislah ayat penuh. Delta H2 is Ca to Ca plus. First ionization energy of calcium. Tak letak first boleh ke tidak? Tak boleh. Sebab kat sini kita ada this one, we have our first IE, and then from here to here is our second IE. So you need to specify which IE you are referring to. So make sure you label first and second untuk IE lah. Okay. And then delta H6. Okay, since the value are negative, so it should be enthalpy lattice of formation. Lattice energy formation of calcium oxide. And last one, delta H7 is equal to enthalpy of formation of calcium oxide. Okay. So that is the answer for number A. Number B, calculate delta H5. 5 mana situ? So kat sini 7 equal to the rest of the structure. So formula delta H7 equal to 1, 2, 3, 4, 5, 6. Delta H1 plus delta H2 plus delta H3 plus delta H4 plus 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. Okay, then we substitute the value. 7 is negative 635 equal to 1, 193, 2, 590, 3, 1150, 4, 248, 5 unknown, 6 is negative, kita tolak je lah ya, plus minus, so become minus 3513. So delta H5 is equal to so my answer for delta H5 is positive 697 unit kilojoule Dia untuk 1 mole of oxygen, so masih lagi kilojoule per mole lah. For this delta H5, make sure you label your, atau you put in your positive sign. Sebab kita guna simbol delta. Delta meaning segitiga tu bermaksud the change in terms of heat. Perubahan, bertambah ataupun berkurang. So you kena ada simbol plus and minus. Calculate the first electron affinity if the second electron affinity of oxygen is 844. Okay, so if we refer back to the cycle above, dia bagi oxygen gas atom, straight away dia produce oxygen 2 minus gas atom. Dan dia label ini sebagai delta H. Sedih sangat. Then the question label here as delta H5. But by right, it should be from oxygen gas atom, dia should produce oxygen minus 1 gas ion dulu. Dan daripada sini baru dia proceed pergi ke yang bawah. So this is the first EA. And this is the second EA. And the question already gave the first EA for this question. Mana first EA? First EA nak kena cari. So this one is unknown. Second EA given to you positive 844 kJ per mole. So what is the value for first? So delta H5 is equal to first EA plus with second EA. Oh, tak muat, so saya pindah ke bawah. So delta H5 we calculated just now, positive 697 equal to first EA kita nak cari plus second EA given in the question positive 844. So first EA is equal to negative 844. So negative 147. Kilojoule per mole. Okay. So itu question C. Now for question D. Would the value of delta H2 be larger or smaller for magnesium than it is for calcium? Explain your answer. Delta H2 apa tadi ya? Delta H2 is first IE. Delta H2 is first ionize. IE je lah, bukan itu kan. First IE. Okay, so IE, kalau ingat lagi pada semester 1 chapter 3 dulu yang assignment tu. So IE is depending on the size. Daripada size, you akan ikut you punya Z tu. If the size is smaller, meaning Z effective nuclear charge is very high, and if it is large, larger size ZEF meaning low. Stronger ZEF, higher IE, weaker ZEF akan jadi low IE lah. Right. So magnesium dengan calcium, which one bigger size? You kena refer balik dalam list at depan table element tu. Okay. So saya tulis kat sini magnesium proton number 12, calcium proton number 20. Okay. So untuk ini you can either using 1s2, 2s2 semua tu, ataupun boleh guna cara SPM 282, 2882, up to you, sebab dia nak tentukan size je pun. Since kita dalam matrix, saya gunalah matrix punya version 1s2, 2s2, 2p6, 3s2. The bottom one is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Okay. So yang nak kita highlight dekat sini, last one is pada period ketiga for magnesium, while calcium last one pada period keempat. So conclusionnya, yang ni yang penting. Size of magnesium atom is smaller. Yang ni key point dia. Then calcium atom. Thus, effective, explain kan? Effective nuclear charge for magnesium is stronger than in calcium. If you want to put into detail, you boleh kata because of calcium has more shielding effect. Saya rasa macam tak perlu, but saya letak saja in case. Okay, saya koma kat sini due to calcium has experience more shielding effects. So conclusionnya, hence delta H2 value for delta H2 of magnesium will be larger than calcium. Should be by right. Ayat ni macam tak perlu sebab this is for sem 1. So should be enough. You say size of magnesium is smaller. Yang ni wajib ada size dia smaller, comparison size. And then just tambah sikit kenapa bila size kecil apa jadi. So effective nuclear charge for magnesium is stronger. So ini point yang kedua. Then kita punya conclusion, therefore the value for delta H2 of magnesium will be larger. So point ni yang itulah yang due to experience more shielding effect ni saya rasa macam tak wajib sangat. Kebiasaannya setahu saya lah, as far as saya concerned, when we are in semester 2, dia punya detail for semester 1 tak sedetail yang kita nak untuk semester 2. This enough to say size smaller. Why size smaller? tadi kita tengok pada dia punya shell ni. Yang ni. So yang ini pun tak wajib tulis sebenarnya. So this one also not compulsory. As long as you know how to determine, that's fine. Dia kata size of magnesium is smaller, therefore it experience stronger effective nuclear charge, hence the value for delta H2 will be larger. Sudah cukup untuk semester 2. Tak perlu detail buat 1s2, 2s2 and then you kena sebut pasal shading effect, no need. Yeah. So because the explanation is for semester 1, not semester 2. Okay, so this should be all for tutorial subjective chapter thermochemistry. So we will continue with calorimeter on next week, Tuesday. So Tuesday we'll start with question number, mana kita skip tadi tu? Question number 7. So 7 until 11 we will discuss on next week, Tuesday. Alright, so thank you and good luck for your work tomorrow. And enjoy your weekend. Walaupun tak lama lah weekend tu. Alright, bye bye. Assalamualaikum. Let's stop. Alright.